Recording again. And now we'll go to, would you rather do 38 or 39? People asked about, I mean, 37 or 39. I think you asked about both of them. Let's try 39 because this one came in from like 2 or 3 different people. Okay, so here I have two poles of heights m and n. They're separated by these angles theta 1 and theta 2. And we want to show the configuration that requires the least amount of rope. Oh, they actually give us the answer. So we want to minimize the amount of rope, which is the total distance of these two red lines here. That's going to be minimum as a function of this where along the ground, x along the ground, where you're going to anchor the rope to the ground. So they're going to walk us through this one a little bit, write an expression for the length of the rope from the top of the first pole to the ground, L1, using only D, M, N, and X. So let me go back to the whiteboard. I'm going to copy this picture on and see if I can't find an expression that they're looking for here. All right, so if I redraw this picture up at the top, over here I have M. We're going to call X the distance along the ground to where that rope comes down. And then this is going to be then D minus X. This is going to be height N. And then I got this piece coming up over here. And this is theta 1, and this is theta 2. And they want me to write an equation for L1, which is the length of the rope from the top of the first pole, which I presume is the one of height M, down to the ground. And so this is the L1 that they're talking about. And I think that I can do that using just Pythagorean's theorem between X and M and L. So L1 squared is equal to X squared plus M squared. Or L1 is equal to the square root of X squared plus M squared. I don't really think that this involves D at all, or N. So I'm going to try to enter that and see if it likes it. Square root of M squared plus X squared. Okay, so they like that. Now they're going to do L2, which is going to be this distance over here, the distance from the top of the second pole to the ground. And so remember, this was D minus X. So we're basically going to do the same thing and get L2 is the square root of D minus X quantity squared plus N squared. And I'll enter that over here. N squared plus parentheses D minus X squared. So now we're going to find the sum of these two things and then take the derivative. So now they're going to again walk us through this. The derivative of L1, so dL1 dx is going to be, this is all to the 1/2 power. So this is going to be 1/2 times x squared plus m squared to the minus 1/2 power, which is 1 over the square root, times the derivative of the inside function, which is 2x. So the 2 and the 1/2 cancels, and I get x over square root of x squared plus m squared. I'll enter that here. And now we're going to do the same thing for L2. And so, as you can imagine, you're going to get this minus 2x from the derivative of the inside function over here. But other than that, everything's going to turn out to be pretty much the same. So the 2 is going to cancel the 1/2. I'm just going to have this extra minus from the chain rule. So I'm going to have minus x over square root, oh, I'm sorry, the 2 times d minus x times minus 1. I'm going to have minus take the derivative of the inside function, I'm going to get 2 times d minus x times minus 1. So the 2 will cancel, but I'm going to get minus and then the d minus x, which doesn't cancel. And then on the bottom, you'll have square root of the same stuff that you had up above. So I'll enter that over here. So minus d minus x is x minus d. Over square root of, and then the same thing I did up here, n squared plus parentheses d minus x squared. And now we're going to add these two things together and set it equal to 0 and solve for x. So I'm going to add these two things together and set it equal to 0 and try to solve for x. So this is not necessarily going to be easy. How can we go about doing this? Let's see. If I multiply through by both of the radicals, what I might want to do is move that d minus x term to the other side. So I have d minus x over that one square root is equal to x over the other square root, and then square both sides. So if I square both sides, I'm going to get d minus x quantity squared over the one square root with the d minus x, and then x squared over the other one. And now I'm going to think about cross multiplying here and see if there's something that's going to shake out of all of this. So this is the square root that has the d minus x squared in it, and this is the square root that's got the x squared plus m in it. So let's see, if I just copy this back up over here, d minus x quantity squared times the square root of x squared plus m squared. Oh, no square root, just the parentheses now because I squared both sides. And on the other side, I'm going to have the x squared times what was under the square root, but now it's squared. So that's going to be the d minus x quantity squared plus n squared. So I don't know if there's any real good way to do this, except just kind of FOIL everything out and see if I can't collapse things together. Boy, I'd really like to just solve for the x. It's that d minus x that's really getting in my way a little bit here. So, y'all have any ideas? All right, well, I guess we'll just kind of do this the brute force method. So d squared minus 2dx plus x squared. And all of that times x squared plus m squared. So that's going to give me x squared minus 2dx cubed, x squared d squared, minus 2dx cubed plus x to the fourth, and then plus m squared d squared minus 2m squared dx plus x squared m squared. And all that now on the other side, we're going to distribute the x squared through this same kind of x d squared minus, oh, you know, that's something that we could have done. Let me just do that step right off the bat. So if I just leave this unfactored, leave it factored, so I'm not going to multiply this out. On the left side, I'm going to have x squared times d minus x quantity squared plus m squared times d minus x quantity squared. And on the right side, you're going to have x squared times d minus x quantity squared. So those will cancel. Plus x squared times n squared. So these cancel on either side. And that'll make this way easier. M squared times d minus x squared equals x squared n squared. And hopefully this will all come together here. So now I could actually take the square root of both sides. M times d minus x would equal x times n, because negative numbers don't really make sense in this context for any of this stuff. And so now I need to solve for x. So md minus mx equals nx. Add the mx to the other side, and you're going to get mx times m plus n equals m times d. And so x is equal to m times d over m plus n. M times d over m plus n. And now we're going to find an expression for theta 1. So theta 1, the tangent of theta 1 is going to be m over x. So inverse tangent of m over x. And then I'm going to plug in what x is. So theta 1 is the inverse tangent of m over x, which is m over md over m plus n. So I'm going to invert and multiply, cancel the m's, and get the inverse tangent of m plus n over d. And now we're going to do the same thing for theta 2. And so theta 2 is going to be the inverse tangent of n over d minus x. And I'm going to plug in the d minus md over m plus n. And I'm going to simplify this by multiplying top and bottom by m plus n to get inverse tangent of m plus n times n all over multiply m plus n times d minus md is just nd. And then the n's cancel. And you get m plus n over d, the same thing that we got before. And I kind of knew that this was going to turn out to be the same because the question said to show that these two things turn out to be the same. Both of the angles have equal tangents, and the angles must always be equal to 0, so the angles must be equal as well. So that's how you do 39. So I'm going to end this video, and then I'll see if you have any quick questions, and then I need to get ready to go up to Calc Camp. But I hope I can make another one of these. If you have any questions from last week or from this week, I can do this little screen recording and, like I said, post it up on YouTube. So do the stop.